So here's going to be two more questions. What's the next number that we're not sure is whether it's in the set or not? So we're now pretty sure 1 is not in the set.
Yep.
2 is by definition. 3 and 4 seem to be tied together.
Maybe 5.
Okay, so 5.
Well,
What about 5? Do you think we're ever going to find a 5?
that would have to mean that 0 is in the set. Well, that's impossible. We can't have a 0 in the set because it's defined to not have a 0. It says positive integers.
Okay, but why, if 5 were in the set, why does 0 have to be in the set?
Because that's the way you would get 5. N is 0 here.
Well, how do we get 4? We don't get 4 from -1. We get 4
Yeah.
from where?
We get 4 from 16.
So maybe if you had 25, then you'd be able to. Well, that means you would have to. Well, to get 25, you'd have to. It would be the only way. You'd have to get powers of 5. You have to get numbers with 5s in them.
Okay, how is that going to happen?
Well, because the only way you can either square root to get somewhere, which will put you with 5 anyway, or you could add 5, which will also give you multiple of 5.
Okay.
Well, we start with a 2, so we're 2 mod 5 here.
Uh-huh.
So you have
And
to-
you're gonna be always 2 mod 5 if you use this step. You
Okay.
just add 5 to it.
Uh-huh.
But to get from n squared to n, you have to have a 5 in the number already.
What do you mean in the number?
Like from n squared has to have a 5 already to get back down to n.
What do you mean n squared has to have a 5?
If you want to get to 25,
Uh-huh.
then n squared is gonna have to have 4 5s in it.
Oh, you mean a prime factor of 5?
Yes.
Ah, okay. So when you say a 5, I wasn't sure what you meant when you said a 5 was in the number. 5 is a prime factor of the number.
Yes.
Okay, gotcha.
But we can't seem to get multiples of 5 in any way.
Why not? That's the important observation. Why can't we
Is-
get numbers that have that are multiples of 5?
You're always 2 mod 5 here with
Okay.
n to n plus 5. It's
Uh-huh.
always 2 mod 5.
Uh-huh.
And then squaring it would be 4 mod 5.
Okay.
So, and then square rooting it is going to get you back to 2 mod 5. So those are your only 2 options for numbers, or 4 mod 5 or 2 mod 5. You can't ever get 0 mod 5.
Okay.
Well-
Go ahead.
We have, mod 5 is just the remainder when you divide by 5.
Yeah.
So we have 54 squared, which is 2916,
Uh-huh.
which is 1 mod 5.
Oh, very nice observation. We have a 1 mod 5 here.
And, yeah.
Okay. By the way, what is 3 mod 5?
What? The number in the set that's 3 mod 5?
What is 3? The number 3 mod 5?
3.
That's just 3.
How about when you square it? What's 3 squared mod 5?
It's 4.
Okay. So when you take the square root of 4 mod 5,
It goes to 3.
well, what's the square
Maybe.
root of 4?
Square root of 4 is 2.
Okay. So you have to be careful when you're doing square roots in modular arithmetic, because in this case there's 2 numbers that go, just like with regular integers, but in regular integers it's easy to see the 2 numbers because they're like plus and minus that number, but that's what's happening here. Mod 5, 3 is minus 2. So you do get the same situation, 2 and minus 2, but they're both in part of the set. But you're right to notice that this 2916 is 1 mod 5.
Yep.
So we have a 1 mod 5. We started with a 2 mod 5.
And we probably have 3 mod 5 in it.
If we get 4 mod 5, we probably are going to find a 3. But we don't ever think we're going to find the number 1. And you guys don't seem to think we're going to find the number, any multiple of 5. Which leads to one last question. How are we going to find a 6?
Well,
Actually, let's go to the next movie for that.